eight three. We're basically done with 8-3, getting ready to start. Yeah, that's the last part of it. So we're gonna start on 8-4. We're gonna take quiz on 8-1 at 1 o'clock. Next Tuesday, 8-4 and 8-5. We're gonna post the quiz prep for 8-4 and 8-5 on Pearson. The quiz prep is so you can get used to taking quizzes on Pearson, because it's different, not the same as homework. So you get 5 attempts at basically the quiz. It's usually more problems than the actual quiz will be, but you get a chance to practice how the quizzes are run. More than one attempt. Then next Thursday, we'll finish up anything left over from chapter 8. That day, the quiz for 8-4, 8-5 will go up on Pearson. You'll get 2 attempts at it, and I'll keep the best of the 2 scores. So if you like your first attempt score, and it's not going to tell you what you got wrong or right. When you click to the next problem, it's not going to tell you how you did until you're done. It's going to tell you, hey, you got 100%. Well, then you don't need to do the second attempt. Hey, you got 85%. Then you decide what you want to do. And I'll keep the better of the 2 scores. Now, I'm going to let it go live next Thursday so you can start when the class is over, 1:15. Here's my question to you. You get to vote. Do you want to have the entire weekend up until Monday night to get it done 11:59? Now, here's my only concern about that. When you get so much time, it's like, I forgot. Because it's, oh, I have until Monday night, no problem. And then you might think about it on Friday. Oh, yeah, Monday night. And then you might think about it a little bit on Saturday. And then by that time, that's the last time you thought about it until Tuesday morning. And it's, the time is fast. You can't do it. And I'm going to get an email saying, oh, I forgot and all that. And, well, that's why you had all that time. Or the due date is that Thursday night, and that way it's like fresh in your head, get it done. How many want it? Or even Friday, if you Thursday, because I know people work, got kids, got things to take care of Thursday to midnight. Who goes for as soon as possible by midnight Thursday? Midnight Friday? 1, 2, 3, 4, 5, 6. Okay, so due date will be midnight that Friday, so you have Thursday and then Friday a whole day, and that way you don't have to worry about the weekend. Okay? So I'll be in 20. Why is it? Okay, so if we can divide that entire number, what can A equal? What can possible value for A? 1. A could equal 1. Any others? No. You say 2, a 4. What else? Any other possible answer? 7. Anything else? Can't have a 10 as a digit. The 10 is 2 numbers, so it's 0 through 9. Yeah, that's a 5, 7, 2, 4, 3, 5, and then that would be a single in the 1 place. So 0 through 9. So a 10 would be a 1 plus 0, just be a 1, so it would help. Okay. If this is divisible by 3, then 5 plus 7 plus 2 plus 4 plus 3 plus 5 plus A has to be divisible by 3. It has to equal a whole number. So 5 plus 7, that's 12. 12 plus 2 is 14. 14 plus 4 is equal to 18. 18 plus 3 is 21. 21 plus 25, sorry, 21 plus 5 is 26. This is 26 plus A has to be divisible by 3. So if it's divisible by 3, you're going to subtract 26 from some number over here, and I have to be able to divide by A and divide by 3 and get a nice number. Well, let's just put it this way. I'm actually overthinking. I don't need to. It's bigger than, also, can A equal a 1? If A equals 1, what's 26 plus 1? 27. So if A is equal to a 1, just 3 going to 27. So A can equal 1. If A equals a 2, 26 plus 2 is 28. Can 3 go to 28? So 2 does not work. If A equals a 3, 26 plus 3 is 29, and 29 is not divisible, so A can't equal 3. 4, 26 plus 4, 30. So 30 is a nice number, so A can equal 4. Start to be a lesson. And if you think about it, if it's going to be divisible by 3, then the answer should be divisible by 3. So I'm just going to keep adding 3 to these numbers. It started with 1, and then we add 3, we get 4. Then the next possible answer is going to have to be 3 more, 7. 26 plus 7 is 33. 27, 33, 30, 33, 36. But 36 would have to be adding 10. 10 is not a digit. So the only possible digits that would work for A would be a 147. Prime time. I'm when we take the test, I don't want to say something that's not true. I can't remember because my brain has got too many holes in it. I have to look. I think it'll be better. I pull them both on. No, only do I not know what I'm trying to find off the top of my head. I don't have a constant. This is the list of the first 100 prime numbers. You can put whatever you want on that little 3x5 card you can have on an exam. So if you want to put all the prime numbers on it, you can, but it has to be handwritten. So you can't cut and paste it onto a 3x5 card with the computer. I prefer it handwritten. That way you at least have processed it from reading, writing to your brain, monkey see, monkey do. Okay. A prime number. Prime numbers are counting numbers. Counting numbers. That means no fractions, no decimals, no irrational numbers. Counting numbers. 0 doesn't work. The negatives are not part of this group. Counting numbers start with the number 1. Prime numbers and counting numbers greater than 1. So if it's greater than 1, does 1 work? Nope. 1 is not a prime number because it's not fitting the definition. It has to be greater than 1. Prime numbers are counting numbers that are greater than 1 that are only divisible by 1 and itself. Like the number 19. The only way you can divide 1 or number 19 is 1 times 19. That's a prime number. So 19 is prime. All the other counting numbers are called composite. The number 10. It's 1 times 10 and 2 times 5. And it's divisible not just by 1 in itself, it's divisible by a 2 and a 5. Okay, another way to say the definition. Definition, prime numbers are natural numbers that have exactly 2 factors, 1 in itself. Now, the thing that's wrong with this, the second definition, is when you say prime numbers are natural numbers that have exactly 2 factors, unless you emphasize the word exactly, you're going to get somebody who thinks that 1 is prime. The first definition says they are greater than 1, so 1 is not prime. Stop somebody on the street, ask them what are the prime numbers, and they'll say 1. Okay? Maybe we'll do that at the Fresno Fair. I'll have you guys have a survey. We'll go to the Fresno Fair. You start talking to people and put it on social media, and we'll get fake numbers. But that's a serious statement. The complexity and the strictness of the definition, greater than 1. So the first prime number would be 2. Versus this definition. Prime numbers are natural numbers that have exactly 2 factors, 1 in itself. The problem with that is thinking everybody understands that 1 is not prime because 1 can be 1 times 1, but exactly 2. 1 times 1 times 1 times 1 times 1. There's an infinite number of ways you could factor a 1 and itself and itself and itself and a 1, another 1 and itself. So there's not exactly 2, but it's a little bit. I don't know. Could get a little confusing. Therefore, greater than 1, only divisible by 1 itself. Okay. The first 100. So this is, it looks like page 20 in your notes. The concept of prime numbers that has been a focus, an important piece of math since 3400 BC. It's still a driving force of mathematics. People are always trying to find what's that next prime number. And they're finding prime numbers with a trillion places. And they're using high-powered computers. There's actually two Russian brothers in a musty, apartment in New York, and I believe it was in the 90s, and they were just using a couple of simple computers, and they found a billion-digit prime number. They made their own algorithm. Yeah, nerds. But guess what? They made the papers all over the world. Okay? There's no formula for finding prime numbers. But we know there's an infinite number of prime numbers. And that was proven. That was proven by Euclid back in 280 BC. Without a doubt, there's an infinite number of primes. So there's substance to this. There's no pattern to it. Right here. The difference between here and here is 1. But then there's 2, and then there's 2, and then there's 4. Okay, so there's going to be another 4. No, 2. And then there's 4, but then there's 2. And there's another 4, but now we have 6. And then you get over here. There's a difference of 6, and another difference of 6, and then a 2. And then a 6, and a 4, a 10. What would have predicted that? So there's no pattern to the differences that have no meaning. Prime numbers are what keeps your money safe. Prime numbers are used to encrypt everything you try to secure on the web. When you turn it into computer language, that's what the password's for. Way above my pay. But it's that prime number generator. Because they can't be divided by another number. And there's a random number of prime numbers you can pick from. Just depends on how high you want to go. Okay. Every level of mathematics has this type, the fundamental theorem. Oh, good. Fundamental theorem of arithmetic, fundamental theorem of algebra, fundamental theorem of calculus. Everybody's got their own little fundamental theorem. Fundamental theorem of arithmetic. Every counting number greater than or equal to 2 is either prime or can be factored into a product of primes in a unique way. What does unique mean? What does unique mean? I know it's the name of Eddie Murphy's children in back in Beverly Hills Cop 2. He had kids, unique moment. Special. One of a kind. Okay. I guess now they use the word uniform. Nothing else like it. So a unique way. So you factor in, when you get it down to its primes, that's it. You're not going to be able to make another way of factoring and factor down to its prime. So every kind of number greater than or equal to 2 is either a prime number or can be factored as a product of primes in a unique way. So if you were going to factor the number 24 down to its product of primes, you would get the same answer for factoring 24. You get the same product of primes. There's no way to get to a different product of primes. Okay, one final answer when you do get it done. Which is what makes math more important. It's that common language, no matter how you do it, the same answer, no matter where you are and what you do. Have you ever seen, I know the answer to this is have you ever at least heard of the movie Contact? Jodie Foster. She's an astronomer. And it's a radio telescope astronomer. And this was probably a movie back in mid-90s. Search for the search for the search for extraterrestrial intelligence, the SETI program. And this is a real thing, SETI. And they would listen using radio telescopes for any signals that exist out there in the universe that might suggest some type of intelligence that is not coming from us. Because there are signals that are leaving our planet all the time. We have radio waves, we have commercial broadcasts all the time. So in this movie Contact, all they do is have the headphones on and they're listening to these, basically white noise that is perpetrated through the universe, or perpetrated through our galaxy. And at one point, she hears like almost a heat. She hears two of them. Then she hears three. Then five. Then she hears seven of them. Then she hears 11 of them. 13 of them. She hears a pattern that represents, she's hearing, it took, her and a few other people working. The pattern of primes. Somebody is broadcasting a pattern of prime pulses. They're using mathematics to communicate intelligence. And that's how, in that movie, they discovered, hey, there's an extraterrestrial intelligence that we made contact with, or we made contact with. And they find more stuff in the communication. They build this thing, and they will find this person, and it's blah, blah, blah. Nice. It's actually not just science fiction. It's a little bit of philosophy, a little bit of religion, a little bit of philosophy, a little bit of Buddhism. Okay. But prime number, the backbone of mathematics. Demonstrate the fundamental theorem of arithmetic. Demonstrate the fundamental. Demonstrate the fundamental theorem of arithmetic is valid with the following counting numbers. That is either state, they're prime, or there are five primes. 27. Is that a prime number? Yes. Is it prime? No. So if you were to use a little factor tree, this would be 3 times 9. 3 is prime, is 9 prime. So you got 3 times 3 times 3. So 27 is a product of these 3 primes, which can be written as an exponent, 3 to the third. And that's the only way to write it as its final prime number expression of product primes. The next one is 59. So 59, 2 doesn't work. 3, 5 times 9 is, sorry, 5 plus 9 is 14. 3 is not working. Again, it's odd, so 4 is not going to work. 5 doesn't work. It's odd, 6 isn't going to work. 7 goes into 56, and then it goes into 60. So 7 misses it. It's not odd, it's not even, so 8's not going to work. 9 goes into 54, then 9 goes into 6. 9 misses it. 10 misses it. 10 times 6. 11 misses it. 12, 13 doesn't go into it. 14 is no. 15. So we missed its prime. So that one's prime. $456. Now, since we are given this little chart over here, the first 100 primes, 456. Well, 456 is not on the chart of primes, so it's a composite. So we should be able to break that down into a product of primes. And I'm assuming, so I don't want to, you've done a factor tree before. Yes, no? Yeah, okay. So I don't care what number you start the division, start to branch it with, you're all going to get to the same final level because that's what the fundamental theorem of arithmetic says. Everybody's going to get to the same number, same values of prime. So 56, you can divide by 4 because 4 goes into it. Or if you just want to start with 2 because it's even, you can just start with a 2. Technically, what I'm looking at is, does 8 work? And I'm looking at this, and I think 8 is going to work, so I can start with 8. 9 plus 6 is 15. 3 is going to work. Well, it's even and 3 works. I could start with 6. So your first number could be a whole bunch of different things. You just got to pick one. What do you want to pick? 2, 3, 4 works, 6 works, 8 works, 9 won't work. So 2, 3, 4, 6, or 8. 8. So this is going to be 8 times 57. And on that 8, you got 4 times a 2, 57. 5 plus 7 is 12. 3 goes into it. This is 3 times 19. You're going to look at 57, you're going to think, well, 57 is going to be prime. But don't forget about your rules or your divisibility. So you got 4 is 2 times 2, because 4 is not prime yet. And then you got the 2, you got the 3, and you got your 19. Please, if you're going to be safe, you're going to get this right. Make sure you bring all the branches down so they're nice and even at the end, or else you're going to leave somebody behind. I've seen this happen. 456, and we start with, that's 2 times 223. No, 28. So then they just do this. This is 2 times 114. And then that's 2 times, that is going to be 57. And then that's 3 times 19. And they don't count all the 2's properly. Because they didn't bring everybody level with all the branches. So we have 3 2's, that's 2 to the third, times a 3, times a 19. product of primes. And it doesn't matter if I start with 8 times 57 or 2 times 28. Start with whatever you want. Okay. The next one. Finding a set of prime numbers. Finding all the prime numbers. What if you didn't have that list in front of you? How would you be able to figure out the prime? So we're going to say hello to an ancient Greek guy by the name of Aristophanes. And he came up with a way to figure out primes way back when, something 100 BC, using something called the sieve of Eratosthenes. He said his name another person, Eratosthenes. Eratosthenes is actually better known for calculating the circumference of the earth using sticks and shadows from the sun. Calculating the circumference of the earth using sticks and shadows of the sun, and coming basically within this about 25,000 something miles, and up circumference of the earth is about 25,000 something miles. Awesome. This guy. Look at that. Of course, he's got knowledge of father of geology. Step by step. So we're going to do the sieve of Eratosthenes. All together now. That's what I'm talking. On your test, you're going to be asked this question. Use the sieve of Eratosthenes to find all the prime numbers from blank to blank. So you're going to be given a start and a stop. And what you'll have to do is you're going to have to list every single number from start to stop. So you get the right amount. Now, you're not going to have to write them out. I will put the list of numbers there. Let's just kind of. And then here's the process. For the first prime numbers all the way to 300. We know 1 is not prime. So you always start crossing out the 1. The next number you come to, that's a prime number. 2 is prime. So 2 is prime. Now, after 2, all of the multiples of 2 are no longer prime. If two divides something, that means you can divide it by two, so it's no longer prime. Because if it's prime, it's only one in itself. So every other number that two can go into, they're not prime. So basically, all the rest of the evens are crossed off. So that's your next step, is you cross off all the evens. It's going to work if you get it. Think about it. I have good health care, and this is what I do for them. That's enough number. The next number that's not crossed off, that next number, that's the next prime number. So the next prime number is 3. Then you cross off all the multiples of 3. Because if they're divisible by 3, it's not going to work. So 3 goes into the next one, 6, but 6 is already done. So the next one is 9, 12 done, 15, 18, 21, 24, 27, 30 done, 33, 36, 36, 39, 42, 45, 5, 8, 1, 7, 7, 16, 60, 66, 69, 72, 75, 8, 1, 1, 4, 4, 90, 6, 6, 9, So, wow. Note to self, don't use till the note five. The next one is who? Who's our next one? Hi. Have any of you heard of what the word sieve before? What a sieve? Now, never heard of a sieve. When I was a kid, how bad it was. Sometimes you would go to a store. There were stores that didn't just sell a bag of flour, pre-packed. They had a bin of flour, and you can scoop the flour into a paper bag, and you would buy it by whatever ounces or pounds or whatever. So my mom would do that, and then she would bring the bag home, and then she would run the flour through the sifter to take out all the crap that's in there with the flour, the rocks, things that might have got in them. And you would sift out what you want. The sieve of Aristophanes is sifting out all the non-primes and leaving us with only primes. So now 5 is the next prime number. So we cross off the multiples of prime. 5, 10, this is a lot easier. 5, 10, 15, 15, 20, here's 25, 30, 35, 40, 45, 50, 55, 60, 65. So technically everything in this column multiple of 5 and that column multiple of 10. So everything in 5's column and everything in the 10's column. And that 10's column is already done because the 10's column would be evens. And the next number is the next prime number, 7. Seven is prime. And so we cross off the multiple of 7, so circle this one. And a multiple of 7, well, 7, 14, 21, 28, 35, 42, 49, 49, 56, 63, 70, 77, 77, 84, 91, 91, 98, 105, 112, 119, 119, 126, 133, 133, 140, 147, 154, 161, 168, 175, 182, 189, 196, 203, 203, 210, 217, 217, 224, 231, 238, 238, 235, 252, 259, 260, 59, 264, 371, 278, 223, so we put 285, 292, 299. That is one. So, you went into the concept. My apologies. I know I think I messed up somewhere. 1437. So I had to go back to the third. 7 goes into that, 21. We're gonna go back to you doing your quiz. I'm gonna fix those. So again, find all the factors. Okay, list factors. And let's make sure everybody understands this next question. The last time we had a leap year was 2024. What is a leap year? Every 4 years, what happens? There's an extra day, February 29th, we have an extra day. Happens every 4 years. If leap year occurs every 4 years, how many leap years will occur in the next 100 years? So between now and 2000, what's 100 years from right now, 2126, 2126, how many leap years are we going to have? Problem. As it tells you right here, for your information, the year 2100 is not going to be a leap year. If you count by fourth, yeah, it should be, but there's a special rule about how the calendars work. If it ends, if one of your hundreds is a leap year, you don't count. So like 1900 was supposed to be a leap year? Nope. We don't count. 2100, not going to count. So 2096 is going to be a leap year. 2104 is going to be a leap year. 2100 is supposed to be, but it's not. How many leap years? Between 2026 and 2126. If the last one was 2024. For you guys, and behind for you. Got too many? Good.